Hello, you are welcome to my class today. My name is Dr. Kingsley. Okay, in my previous class, we were discussing the chemical reactions of alkynes. Okay, but we did not end up with that reaction. So today, we are going to continue the chemical reactions of chemical reactions of alkynes. But let me recap on what we did on chemical reactions of alkynes. We will discuss combustion reaction. Then we also discuss addition, but not all additions. We did addition of hydrogen, addition of bromine, addition of hydrogen halide, then addition of water. That is number 4. So today I'll be continuing with what number 5, which is addition, okay, of bromine water. So number 5 is addition of bromine water. Okay, bromine water. We can use chlorine water, but it's okay. Anyone is okay. So if we are using bromine water, we are having an alkyne reacting with bromine water. Let us use a propine. Propine, okay, reacting with a bromine water. Remember, reacting propine with bromine water is just like adding hypohalous acid, that is hypobromous acid in this case. Why? Because bromine we react with water, okay, to give us hypobromous acid, okay, plus hydrogen bromide, that is HBr. Okay, so what is actually being added up to the multiple bond is this, which is a hypobromous acid. Remember, the hypobromous acid is Br, then OH. Okay, we need 2 molecules of this to fully saturate what? The alkyne. 2 molecules. So here is 1 molecule. So if this bond breaks, one of these will be added to either carbon of the what? Of the triple bond. So, but if you look at the carbons of the triple bond, you see that one have what? Hydrogen, while the other does not. So the addition will obey Markovnikov's rule. So OH will be added to the carbon atom bearing higher number of hydrogen, while bromine will be added to the other carbon. So if we add these 2 groups to this triple bond, one of the bond will what? We break, one of the pi bonds. So what we'll be having is we'll be having CH3, okay, C, double bond C, we have a Br, okay, and OH. So one of the bond from here has broken because we have added groups. But I told you that we will need 2 molecules of hypobromous acid to fully saturate this what? This propine. Okay, that means another hypobromous acid will be added. Okay, obeying what? Once again, Markovnikov's rule. We see that OH will be added to the carbon bearing higher number of hydrogen, while bromine will be added to the other carbon. So if we do that, we'll have OH, okay, and Br. So since we added another group to this, okay, bond, one of the bond will do what? We go. So that we have this as our product. Now, but we can see some rearrangement here or elimination of groups, because this is what? This OH is O and H. Okay, the bond here of the hydrogen can come here, so that what? So that OH will leave. So the bond of hydrogen comes here, then the OH leaves. So what we'll now be having is CH3, okay, Br, we have Br, then you have C, double bond O, because this bond have come here. Then you see that the OH have left. The OH combines with what? With the hydrogen to give you what? H2O. So that is our final product. So what we have is what? Keto dihalide. So anytime alkynes react with bromine water, we'll get a final product, which is what? Keto dihalide. So that is the reaction. So the next reaction is reaction between alkynes and the acidified solution of KMNO4. Acidified solution of KMNO4, okay, is an acidified solution. Now if we take a butane as our alkyne, okay, if we take a butane and we are reacting it with a KMNO4, okay, KMNO4, the compound we have is a CH3, COH, OH, then COH, OH, and CH3. That is the compound that will be formed. Remember, the acidified solution of KMNO4 is a solution. So as a solution, there is a presence of water. The oxidizing agent is donating oxygen. Okay, when you rearrange these two, you will be having OH, then OH. So you see that when the bond breaks here, you'll be having one OH attached here and one attached here to give this. But this here requires what? Two molecules. So another of this attaches here, and the next bond what gets broken. Then this product that is formed here, if you look at it, there can be what? Rearrangement of atoms. This is H and this is what? And H. This atom of hydrogen, the bond here can come here, while the bond of this one can also come here. When the bond of hydrogen comes here, okay, OH will leave, and here OH will also leave, so that the final compound that we'll have will become CH3, okay, C double bond O, then have C double bond O, then CH what 3, then plus what? Plus 2H2O. So that is the final product. So anytime that alkyne react with a acidified solution of KMNO4, what will be the final product? Will be what? A dione. Now if we number this is 1, 2, 3, and 4. This is buta 1, okay, buta 2,3 dione. So that is the final compound that is formed.